The next tool is Theano. It's a optimizing compiler for evaluating mathematical expressions on CPUs and GPUs. It's a Python library that allows one to define, optimize, and efficiently evaluate mathematical expressions involving multi-dimensional arrays. It is built on top of Numpy. The features are tight integration with Numpy, very similar interface to Numpy's, numpy.nd arrays, useful internally in the Theano-based compiled functions. So that makes the things run faster because it is directly compatible with the NumPy's ND arrays. It has transparent use of GPUs, performs data intensive computations up to 140 times faster than on CPU. Efficient symbolic differentiation. So Theano can compute derivatives for functions on one or many inputs. Speed and stability optimization. So it will avoid nasty bugs when computing expressions such as log of 1 plus e to the power x for larger values of x. So usually what happens is when the value of x is larger, exponential of x becomes too large to hold in the data structure, and because of that the value goes erroneous. But if you look carefully, it is log of e to the power x supposed to be x itself, but due to the data structure problems, it's going to be erroneous result when value of x is larger. Dynamic C code generation. Because of this, the expressions are evaluated quite faster. Intensive unit testing and self-verification includes tools for detecting, diagnosing bugs and or potential problems. So features stability optimization. Theano can find out some unstable expressions and make use of more stable means to evaluate them. Execution speed optimization, as mentioned earlier, Theano can make use of recent GPUs and execute parts of expressions in the CPU or GPU, making it faster than Python. Symbolic differentiation is possible. So Theano is smart enough to automatically create symbolic graphs for computing the gradients. Symbolically, we can see how Theano can be made to work. Here we are trying to find some function that is x times w plus b. So here x is a matrix, w is the weight vector, b is the bias. So that's a very commonly found expression in any data science or machine learning algorithms. And here x and w we can represent with a dot multiplication, and then there is one scalar b which is supposed to be added to all the things. So the dimension of x is increased, so it makes equal to dimension of w. So the number of values B are made equal to number of elements in W or number of rows in X, whatever way we call it. And then at the end, they are being element wise operations are performed. So X dot W comes from one side, some half value comes from other side, B comes from one more side. All these values are element wise operated. Some composite expression like negation, subtraction, negation, then applying scalar sigmoid function or something as an example shown here. So that would produce finally one tensor vector, which is what we usually call Y. So this freedom we have to represent the operation in the form of a graph, and that is supported by Theano. So much more complicated expressions can be put very human friendly way, so that a lot of coding can be avoided, and makes more sense if the things are represented graphically. Then understanding it, presenting it, creating it, finding the bugs in this, finding the mistakes and all that becomes easier. So that's other tools are on the way in the coming sessions. So keep watching. Thank you.